Welcome to a new episode of Mostly Engineering and another part in our Enigma Build series. So welcome to this episode and welcome back to the Enigma Build project. I know it has been quite a while since the last video, but unfortunately time wasn't on my side in the last couple of months. But that's hopefully to change. And I have to say I'm feeling really motivated and really ambitious, because in this episode I try to finish the stepping mechanism for the rotors so that we can see the rotor moving on its own power, so to speak, for the very first time. Gonna be exciting. And the other exciting part is for the rotary build, I will try to see if we can machine 3D printed resin on the milling machine without the resin cracking or crumbling under the tool pressure. So, with no further ado, let's go over to the workbench, take a closer look at the parts. So, and here we have our 3D printed parts, freshly out of the printer, and you see the surface over here. We still have the supports, and the usual way would be to sand it off, but as this surface is a little bit wonky, you usually also sand it a little bit wonky, and this is a problem we had on the old rotors, that because this wasn't perfectly straight, the axis didn't sit perfectly straight, and therefore the rotors wobbled some by quite a bit. And what we will do today is I extended this part about 1 millimeter over here, so that all where we have the supports, where the first layer is formed, and therefore the part gets a little bit wonky. We have enough meat that we can just machine off, and therefore have a really nice machine surface over here, and then the parts should fit perfectly and we don't have this wobble. Machining resin is usually tricky, but what I used here is Ceratec Blue, and I made the experience that on lathe you can work with this resin without it shattering or breaking like every other resin I know. So I hope it works on the milling machine as well, and when we are ready, we have all our 3D printed parts cleaned up with nice machined surfaces. So let's go. So, and here we have the machined 3D printed parts, and as you can see, hopefully you can see, this is absolutely straight surface, and mounting this straight will be absolutely no problem. So really happy with the result. It works more or less flawlessly. The only thing you have to keep in mind, because you can see here some breakouts, especially where the parts were really thin, is that you have to keep in mind how the cutter is moving. So when the cutting edge is moving out of the material while cutting, then these breakoffs can happen. So you have to make sure that the cutting edge is always moving into the material, and then you will have a really nice surface. Here it's not a problem because we sand over it slightly, and then sells this as a little bit of weathering, no problem. But yeah, overall, machining this type of resin works out really, really nicely. So that worked actually really nice. And now let's go over to the stepping mechanism, and we will start with the rods and all the bushings here. And this will be some really straightforward turning operation. So with no further ado, let's go over to the lathe. And here we have the finished mechanism. I mean, sort of, as you see there, the green and the black parts are still 3D printed, and we have to do them in metal at some point. But main reason for not doing it yet is that I didn't have the material at hand, and I didn't want to wait. I didn't want you to wait another 2 or 3 weeks for the video go up. So I 3D printed it. Another big advantage of the 3D printing is that we can see if everything fits, if all the measurements are correct in a very, very cheap and quick manner, because I think not all the measurements here are entirely 100% correct. To actually verify it, we need to finish the correct rotors first, but as soon as we do it, we can make that and then finalize the designs. And of course, I already came up with a little design fix here and there, but this is for the next video. The interesting question, of course, is now, does the rotor actually move? And I'm very happy to say yes, it does. Of course, at the moment, I still have to give it a little bit of a helping hand because nothing is pinned down there, so the springs are not working. But if I give it a helping hand, you see that the stepping mechanism works absolutely flawless unless the flimsy 3D prints get in the way, and it blocks a little bit, but this is very quickly corrected. Very nice. And another big question I needed to answer is if this lever shape is actually correct, because we have the lever and the post for the retaining spring over here, and they are in the same position, so there must be a mistake somewhere. But now we are in the closed position, so let's correct how this should sit better, and we see we still have pressure on the registration drums over here, and so our rotor is sitting nicely and securely. And when we open this up, also very satisfying click over here and correct the position, then we see we have a free spinning rotor. We can take the rotors out, change them as we please. So very nice. The shape of the lever seems to be correct, and it seems to be the position that is wrong. What is also a very nice outcome, because the position is much easier corrected than the lever shape. And yeah, so far it works, and putting everything into metal is for the next episode. And on this high note, it's already time to end the show. And I hope you enjoyed this as much as I enjoyed seeing this rotor move for the very first time. If you have questions, comments, as always, let them down below, and I try to answer them as quickly and correctly as possible. And all that's left to say now is thanks for watching, and see you at the next time. Bye bye.